And you may know that nowadays the energy consumption, or we may say the most energy consumption component we found in a building is the HVAC system. It occupies around 50 to 60% of the energy in a building. Now, therefore, what we are going to do is that if we can predict the energy usage of the HVAC system, we can have some more tailor-made strategy to control our HVAC system so that we can save our energy. Our goal is to save the energy. And what we are doing here is to predict the load forecasting of the HVAC system. Like instead of using the reactive one, we're using what we call the proactive control. So that nowadays we are talking about using some advanced prediction model doing by deep learning approach, analyze the time series. At the beginning, we are doing something, the regression model, such as the auto-regressive integrated moving average. They are the baseline. And we evolve to become some more advanced model using the recurrent neural networks nowadays to develop something very complex, non-linear dependence model. And basically, up to now, we cannot describe very clearly about how the neural network work. You know, it is a very difficult topic to describe. But from the output, we know the neural network actually perform very well. Just like you are using the ChatGPT, it can answer you everything. Now the model, most likely we can develop something very commonly used in nowadays the prediction model. It is so-called the long short-term memory, or in short, the LSTM model. And it is one of the typical model applied to the time series data. From the name, you can think about that it has something short memory to bring into the nearby data into analysis. And at the same time, it captures the long periodic behavior of the signal into the model. Therefore, it is now very efficient to predict the data, the time series data. And on the other hand, another very useful model, it is the gate recurrence unit. And it is more or less similar to the LSTM. You can see in this model, it is using two gauge version so that it has two branch. Okay, you can parallelly using these two branch to predict the data. Okay. Now, by doing or applying the neural network into our prediction, we are talking about doing the feature engineering. And what we are going to supply to the neural network, including the load data. Okay, you may input something like 24 hours data, 1 month data, or even 1 year data. Now, in this talk, I would like to give you a demonstration. I will supply a model with a 1 year data. Okay, so that you collect the data and then we train up the model in order to do the prediction. Now, also, we may consider something periodically appear in your data. For example, the calendar variables, the working days or holidays, etc. Or even the weather forecast. But we may rely on some high quality, high resolution weather forecast. The high quality means it is accurate. Okay, and high resolution means we may collect the weather data in a very fast interval, for example, 15 minutes. Now this picture shows what we are doing. Firstly, we are doing to the left-hand side. It is the beginning. We collect the data using some sensor. For example, the thermometer, the humidity sensor, etc. And this data will be exploration so that we may have some screening, filtering about the data. And then doing the pre-processing, doing the normalization, feature selection. All the process basically require some time to describe. And today I don't want to describe the data processing to you. And here we only showed you something, a conceptual idea what we are doing in our model. And after you prepare well the data, you will feed the data into your machine learning model. You can see many machine learning model just look like a leg. Okay, it indicates it is a neural network. Now the neural network itself, we try to model our brain, the human brain. Okay, and you can see in the network we have many loops, and actually it represents the neuron in our brain. Okay, now and at the end, after the train up and we apply the model, and it can predict our load at the end. Now this is the full of our model, and our goal is that you can see this is the diagram shows you the prediction result and also the actual data. Now let me talk about a little bit about this graph. Now you can see the black line, it is the actual load. Okay, the black dot. Okay, and we can develop many different models to evaluate the behavior or the performance of the model. You can see we have the blue line, purple line, and the red line. Now more or less, because the diagram is not so big, you may not see it very clearly about how the model fits the actual data. But now, from a very quick view on this graph, you can see the prediction model are doing quite well because the pattern can follow the actual data already. This is what we hope we can have in our output. Okay. This is only a comparison on the actual data to your predicted data. And how can we do that? Today, I will show you the method on how we can do that. Now, for the using the LLM in generating the code, you may following the some procedure I put down here. Now, I do not spend time on that, but you may say that firstly you are doing the data pre-processing and feature engineering. So that means you are going to well prepare your data before you input to the LLM because by using the machine learning model, one of the jargon we may talk to the other is that garbage in and garbage out. If you want to have a better output, that means you needed to give your model some clean data. Otherwise, it may give you some rubbish. And then you may select your architecture, the model, because we have many machine learning model we can use. Therefore, you may ask or choose your model. And then during the process, you may need to do some debugging. Okay, and finally, you may, after the model work, you may pay some effort on optimizing the output of your program. Okay, and one of the idea that we remind you here is that don't just put down a prompt saying write the whole project for me. Normally it doesn't work. Okay, you may guide the LLM to write the program. Okay, otherwise I don't think you just write a single sentence, it cannot generate the program to you. Now on this page, it shows you some commonly used chatbots. Nowadays you can use some are very famous. the OpenAI, DeepSeek, Coq, ChatGPT, Cloud, Gemini. They are very popular nowadays. So which one do you think is the most powerful one nowadays? Do you know? ChatGPT? DeepSeek? Now, if you read the news from the machine learning a week ago, I may say nowadays the most powerful AI platform should be Gemini. Okay, because after it just released a new version, Gemini version 3. It outperformed the other AI platforms already. So tonight, I'm going to using the Gemini to help the demonstration to you. Now, what we are doing is that is doing the prompt engineering and how can we generate a good code. This is some hints or guideline. You are going to tell the AI your goal. Okay, what you are going to expect to be outcome, and what data you are input, the context. Okay, and also you may ask the AI to help you to prepare the output in a suitable format. Therefore, you may also tell the AI to generate the output format to you. Okay. Now, as I said, we are using Gemini. So I prepare some example to you. Now, I prepare the data that we would like to input to the Gemini. This is the Gemini. And firstly, you may input the data, the data set. The data set are using now today. It is a 1 year data that I told you before. It is collected from a HVAC system. Now, when you open it, now you can see it includes a timestamp. Okay, we collect the data from 1st of January to 31st of December 2024. Okay, we have the building ID. This is the chiller power. Okay, the water temperature, etc., etc. Now, I'm showing you how we can predict the chiller power today. Okay, the other prediction you can do it by yourself. Okay, now the data set and everything I will upload to a shared drive to you at the end. I give you a QR code. You may download the data set to try by yourself. Okay, I will show you later. Now I upload the data set into the Gemini. Okay, just copy to the Gemini. You can see the data has already uploaded to the Gemini. Okay. And then we can input the prompt. Now, the first prompt I would like to demonstrate to you is to generate a robust Python program that takes the timestamp column from a data frame, extract the hours and day of year, okay, and convert into sine and cosine cyclic features, okay. Now, why we do that? Because if we are doing something relating to LLM, we needed to prepare the token. Okay, you may consider the timestamp is the token of the LLM. So now originally I needed to type, but because I have already put down the prompt here, therefore I just copy and paste, and then press 1. Okay, it spends some time, but it should not be long. Now you can see the Gemini basically analyze your file. Okay, it know already it has the hour and also date of the hour, and finally it generate a program here. Okay, now because this program it is so simple, therefore it doesn't run it in the Gemini. Okay, and actually, it has already run the data to you. You can see the hour sine parameters, hour cosine parameters, date of year sine and date of year cosine. You can see from the program, it already makes some equation, generates. Okay. Now, as you are a supervisor of the AI, you may need to check whether the equation is correct before you apply the program. Okay. And if you want to have the file about the data, the generated data, you may press the export to sheet. Then you can see it generates some first 5 data to the program, from the program. Okay. And actually, what you can do is to run the whole data in order to generate all the parameters. Okay. Now, this the first demonstration does not show you any prediction. It only shows you how can we collect the data. And what we are doing here is to run the second prompt in order to fill in the missing values inside the data. Because if you open the data file again, you can see some of the data are missing. For example, in the cell D55, the data is missing. Okay, this is due to because in the data connection, some of the sensor may be break down at that instance, and the data is missing. Therefore, at the beginning, what we are doing is to fill up the missing data. Okay, so we ask the AI to write up the program to help us to fill up the missing value. Okay, especially for the chiller power. So we just write a prompt. Okay, another a few seconds, you can see the program, the Gemini already writes the output to you. Now, the reason why today I demonstrate the Gemini because the program can directly execute inside the Gemini. Now, you can see at the right-hand side, we have the program again. And this time, you may see we have a button. It is a one code button, and you can press on it. You can see it generate the output to you. It shows you where you fill up the data. Okay, this is the output already. Now, but I may say, sometime when you try the Gemini, can you run the program directly inside? Therefore, you can see we rely on another important tool. This is the export to Colab. Now, Colab, it is another services provided by the Google. Okay, so when you open it, it shows you again the program generated by the Gemini. Okay, and now what you can do is that you should upload the data file to the program. So what you are doing is just drag and drop the data file into the Colab. Okay, now you can see the data is here, data file is here. And now you can run the program by pressing the play button here. So you can see at the bottom, it shows you again the results. Okay. Now, therefore, other than the performance of Gemini, you can see the Google has provided you a very complete or comprehensive environment for your program development. Okay. Now, this is the second step. We are doing the data cleaning. Now, how about next? Now, we are going to generate a baseline model. Okay, we are using the random forest regressor, using some package. Okay, and it asks the program to generate some performance indicator such as the root mean square values or mean absolute value. Now let's see how the Gemini help us. We come back to here. We can close the program. Now you can see basically the program is written can always be reopened again. Okay, don't afraid that they are eliminated already. Okay, now you can see again without a few using a few seconds, you can generate the program to you. Now we have multiple methods to run this program. Okay, but I am now trying to copy and paste the program because this one can using the collab that we already generated. Okay, now we come back to the collab, and then at the bottom you can insert a new program code here, and then paste. Okay, we paste the program there, and then press the run button. Now you can see because it is now training a model, and then it spends some time. Okay, you can see now the training is completed, and it generates the root mean square value and also the mean absolute value to you. Okay, now but you may say, oh, for this model, how can we apply the model in prediction? Therefore, you may ask the Gemini to modify the program by saving the model into a file. So now this time I do not write it in a PowerPoint. Therefore, I write it directly at the prompt. Let me do it. Now you can see I put down a command. We ask the Gemini to save the model in a H5 file. H5 file, it is a model file. It is going to store the machine learning model. Okay. Now you can see it generates a new model to you. Okay. Now I don't spend time on describing the program structure to you, but I only demonstrate to you the performance or the output. Okay. Now you can see in this model, let me see. Now let's try. I can't see it. Then write it again. Okay, no problem. Again, we're using copy and paste. Add a new program, and then run the program. Okay, it seems it does not say. Oh, yeah. Now you can see it create a new file here. Okay, this is not an H5 file, but instead it is saving it into a file so-called job library. Okay, now it doesn't matter because once you generate the model, you can apply the model again in your prediction. Okay. Now, so you can see we have a new model here. And then you can download it for your own use in other platforms. But now let us continue to demonstrate. We are doing the prediction. So we ask the Gemini to help us to generate the 7-day prediction data. Now we just ask the Gemini to write a program to predict the 7-day load using the model. Let's see the program. Again, you quickly generate the program to us. So let's again copy and paste. And run it. Okay, now you can see it predict the data for 2025, 1st of January. Okay, using the model, the data. Okay, and now actually this is a simple demonstration on how can you make the prediction. And in fact, this process you may repeat it because sometimes you may find the data or the prediction is not that accurate, or even sometimes the Gemini may generate some error in your program. Okay, and now, for example, if you found, let me see. Now this is the random forest that we ask the Gemini to generate for us. And sometimes you may find when the program is executed, it generates the error. So you may ask the Gemini to help you to fix it also. Now, but in my demonstration, it generates a correct program that I cannot demonstrate to you how can we fix the error. But when the error happens, you just copy the error, come back to the Gemini, it will help you to fix it. Okay? And how about we may modify the program by including the other data? So you may, this time you may ask the Gemini to including in the prediction model, more parameters should be sold. So let's see what happens. Now it generates a program to you. Now, but now it is a new program. Sometimes it may modify the old program in order to include this part. Now, and this time it generates a function to you. So you may ask it to integrate to the training program. Okay, so you can see it is trying to add this function into your random forest training program. So where is it? You can go back to find your random forest training program. This one. Now, when you open it, okay, you can see your new function has been added there. And then you can, again, copy and paste. Now you can see now other than it calculate the root mean square value and also the mean absolute value, it also calculates the new parameters to you, the coefficient of variation to you. Okay, so you can easily modify your old program in the Gemini or the other machine learning model. Okay. And after you generate the baseline model, you may ask the AI to generate using the other model, just like what we told you at the beginning. We may using the LSTM model, using your specific parameter in order to train up the data. Okay. Now this one I won't demonstrate to you. I may leave it for your own question. You may try it later. Okay. Now we come back that actually you may see other than the Gemini or Colab, you may after you generate the program, you may want execute the program in other platform, just like the Anaconda, Jupyter, etc. Or even Google. Basically, it offers a very comprehensive workspace, the AI Studio, so that you can run your execute your program there. And let me introduce a little bit about the program. And actually, this part of the subject that I demonstrate to you come from a program, the Master of Science in Smart Engineering and Construction, offered by PolyU SPEED. And it is a QF Level 6 PolyU program, and it offers mixed mode. You may spend 1 year for the full-time study, or 2 years part-time study here. And both of them, no matter full-time or part-time, the program contains 31 credits. I make a typo here. It should be 31. Okay. And the entrance requirement, if you already hold a bachelor degree relating to engineering or science or technology, you are eligible to apply this program. Or if you have your age over 25 with some professional knowledge in the field, you are welcome to join this program. Now about the program, now you can see the program consists of 10 subjects or 11 subjects. And one subject, we call it the academic integrity. This subject, every PolyU master degree program will have this subject. Okay, because we hope our graduate have the academic integrity. Okay, therefore we offer this subject. And the other subject, you may consider that they are the core subject relating to the engineering discipline. We have 5 other compulsory subjects at the top. Okay, the Web 3.0 technology, building information modeling, environmental assessment and control, advanced intelligent buildings, safety aspect and management. Okay. Other than that, we have 15 credits or 5 subjects you may choose as your elective subject. Okay. Now, in the elective subject, we have 2 study modes. You can either select the dissertation mode or long dissertation mode. Now, for the dissertation mode, that means you pick up a dissertation equivalent to 3 subjects. Therefore, you can see it contribute 9 credits to your study. Okay. And if you select the dissertation, that means you follow our academic staff to complete a project. Okay. And other than this dissertation, you needed to additionally take up 2 other elective subjects, okay, as your elective subject. On the other hand, if you choose non-dissertation option, you can directly choose 5 subjects inside this pool. Then about PolyU SPEED, actually we operate for more than 25 years, and we train up more than 15,000 graduates already since 1999, and currently we have more than 300 academic staff in the college with specific and professional knowledge. Now, about PolyU, I think you should know very well about PolyU, and it is a well-famous university. And the QS just released the university ranking for 2026. PolyU is now ranked at 54. Okay, and we are a part of PolyU, so that if you graduate from this program, you own a master degree from a famous university. Now, this is our attachment. You can see we have the PolyU logo together with the School of Professional Education and Executive Development